Chapter 10, Number 29. A compact disk, which has a diameter of 12 centimeters, speeds up uniformly from 0 to 4 revolutions per second in 3 seconds. What is the tangential acceleration of a point on the outer rim of the disk at the moment when its angular speed is A, 2 revs per second, and B, 3 revs per second? This is kind of a goofy question because it's accelerating, as they say here, uniformly. So the acceleration is not going to change no matter what omega is. So really we said that part A and part B will be the same answer. For those who might not know, a compact disk is a circular platter that is used to store data, traditionally music, but other data. It is sort of dying out, but slowly. Anyway, it is a circular thing, which is all we really care about. And so we want, according to them, what we want to get is the tangential acceleration. So that's a sub t, and we know that a sub t is going to be alpha r, where the radius is r and the acceleration is alpha. The angular acceleration is alpha. This really follows from the idea of saying that the velocity tangentially is r omega. And so when we take delta t of both of those things, we get the thing in green. So all we really need to do is figure out alpha and then throw it into this formula. So here we're going to say, well, what are we given? The initial omega, which is this. So omega initial is 0 revs per second. And we're given the final omega, which is that. And that is 4 revs per second. And then we're given a time. So we're given that delta t is 3 seconds. So that makes life relatively easy because alpha is delta omega over delta t. So it is 4 revs per second minus 0 revs per second all over 3 seconds. And then I'm going to do a conversion because I want to be in radians to make everything work out right. So I'm going to say there are 2 pi radians per rev. So let's take care of that up there. And we end up with 8.3775 radians per second squared. And in fact, we have 3 sig figs everywhere. I'm going to carry this for the moment to 4 sig figs because we want to make sure that our calculation doesn't lose stuff later on. So I'll round to the right number later, but generally I'll carry an extra one. From here on out, it's actually almost trivial. The tangential acceleration is, as said before, alpha r, so it's 8.378 radians per second squared times, and then the radius is, we should be careful with that, it's 1/2 the diameter, which is what we were given here. So it's 1/2 of 12 centimeters, and I should convert that as well so that I end up in standard units. 1 meter is 100 centimeters, and then we can grind out that number. 0.50268 meters per second square. Now we go to our 3 sig figs and we say 503 meters per second squared. As mentioned before, the answer to B is also going to be 0.503 meters per second square. There's really no work to be done because I said the acceleration was uniform.